Is the panel ready for questions now? One of them is. One is. Two's good. Amy, you good? All right.
Okay, so this question is actually for Ben. Regarding the fission from hyperinsulinemia.
Speak up.
Okay, so regarding the fission with hyperinsulinemia and insulin resistance, is there any benefit to that? For example, the insulin resistance of infection or injury or anything like that?
That was a good question, I guess.
Yeah, that's neat, Sean. I've never thought of that. Well, it's neat. It's interesting that you invoke infection, and you think of the fever and the prostaglandin-mediated kind of uncoupling of the mitochondria. I'd mentioned how when the mitochondria are forced into this sustained fission, their ability to produce ATP is down, and it appears that there's more H2O2. And that alone could, in fact, suggest some overall uncoupling, which would promote fever, which is, in fact, therapeutic, in order to create a more hostile environment to the pathogen. And then perhaps the cell's ability if it's forced fission, producing more H2O2, maybe that enhances the phagocyte's ability to engage in what I call the oxidative burst, to basically blast the pathogen with the reactive oxygen species and kill it. How's that? I'm speculating though. I don't know. Okay, yeah, she bought it.
I want to thank everyone, but also Amy and Ben in particular for praising oxidation, because I'm going to do that too, and I won't sound quite so crazy if you've already said it.
We greased the skids. Bacon greased the skids for
That's
you.
Right. My question is for you, Ben. One thing that I didn't quite understand, mitochondrial biogenesis, I thought happened through a process of fission. So if there's fission is reduced, how is the biogenesis happening?
Yeah, I can't. Yeah, so overall number, I guess, yeah, Amber, we'd have to define mitochondrial biogenesis, and let's define it. Let's agree that we'll define it as overall mitochondrial mass, which won't be the same as fission or fusion, but when a cell is about to divide, you must have fission. In order for that the mitotic process, it needs fission. And so you've split up the mitochondria, and now they can split into the daughter cells, and now they can come back together through fusion. So I don't want to say that biogenesis is either fusion or fission, but rather the overall mass of mitochondria within the cell has gone up. That'll work.
Yeah, that's very enlightening. Yes,
Okay.
Thank you.
All right, this guy needs an introduction. This is Roy from Keto Conduct.
How's it going? So this is for anyone on the panel. I'm just curious on if you're at a ketogenic level, how can you build muscle with the lower insulin levels?
I love that. So you always have insulin going, and as you can see, there's never not insulin present. The issue is that the ketone actually stimulates the preservation of tyrosine and leucine, and stabilizes that need for muscle development. It also raises testosterone by 50% by itself, and so you have an enhanced testosterone, enhanced tyrosine and leucine presence, and you have a baseline insulin. You're going to generate muscle, and I see it in 75-year-old women who come in saying, I gained weight, but their waist shrunk, and when we body mass them, they end up having gained muscle mass. And it happens every day.
Well, I'll say in our study that we published, and it is, I think it's a freely available one, we found that overall resistance to noxious stimuli of the muscle cells went up with BHB. So the muscles were a little more robust, more resistant to injury. But to add to what Adam mentioned, looking at insulin as anabolic to muscle is, in fact, I think, a bit of an exaggeration, where insulin is really more anti-catabolic. And that's not the same as anabolic. There are distinct anabolic activators to muscle, and insulin is more anti-catabolic. And as Adam mentioned, it's always there, presenting this kind of underlying fight against muscle catabolism, and yet it's other signals that are truly promoting the anabolic signaling.
Thank you.
I would just add one tiny piece, which is why I think, depending on your particular situation, if you're looking to build muscle mass on a ketogenic diet, you probably really don't need to be afraid of protein, because protein does have an insulin effect. But I say insulin effect, I very deliberately avoided the word spike. Protein doesn't spike insulin the way, sugars and carbs do. You have a normal physiological rise in insulin that you want to get from protein. So as long as you're eating enough protein, you can probably build muscle on keto.
So I'm embarrassed to say that up until this very moment in time, it didn't even occur to me, Ben, that you've done more with rodent models in a ketogenic diet than probably anybody else I know. So
Unless you know Dom D'Agostino, but he's done a lot more than me. But Dave, I don't know if you should even get that. You fell asleep during my freaking talk. I mean, I saw. Don't think I didn't see. In fact, I'm not even listening anymore. I was trying to get Brett to elbow you awake.
To be fair, I've literally.
I'm used to it. Remember, I'm a professor. If I can keep even half of the students awake, it's a win.
No, if you saw my talk, my Oura ring has been screaming at me for the last week and a half because I've gotten about 4 hours of sleep a night. I'll show you the readings. I'll show you. But anyway,
I don't care.
Real quick.
Dave, more excuses. Finals week just passed, Dr. Bikman. I've heard them all.
It's also I can repeat your class though anyway, so it works out.
Yeah.
So real quick, you worked obviously a lot, and rodent lipid systems are obviously going to be very different. But I've got to ask: have you been taking lipid metrics on the rodents?
No, not at all.
Ah.
But in fact, you know what's interesting? Relevant to both what you are maybe thinking, what Siobhan asked. If you put a little bit of lipopolysaccharide, LPS, into a human, they're going to get septic quick. You can't kill a rodent through sepsis. Their immune response, and I mention this with regards to lipids because LDL is so good at binding LPS, this pathogen, and just dumping it through the bile duct, out of basically squelching this pathogen. And it's basically impossible to kill a rodent through LPS, through sepsis. In a human, no, they're gone, but not a rodent.
Yet more reasons why rodent studies are so hard to watch when it comes to lipids. Anyway,
that's true.
Okay. Well, then my follow-up question doesn't apply. Thank you anyway.
Hello, this is for Dr. Nalley. So when you were talking about the thyroid and watching all the levels and the numbers and such, so how different, or is it different for a total thyroidectomy and now on levothyroxine to manage that?
So that's a good question. One of the things I realized I didn't really say much about was when you're supplementing thyroid, like levothyroxine, you're giving T4, and you're essentially replacing what the thyroid would do, or you're supplementing what the thyroid would do. That T4 is going to act identically to what the normal thyroid would do. So if you're missing a thyroid and we're giving you that T4 hormone, it's going to be converted into T3 or into reverse T3 if you have diminished deiodinase 1 enzyme. So that's with high insulin. So either way, whether you have a completely functional thyroid that's producing that hormone or whether you're supplementing it, it's going to respond identically.
Okay.
At least that's what I see clinically.
All right. Thank you.
Hello, specifically Ms. Berger, but anyone else who would like to answer. When I was in nutrition school, we learned that there were very distinct types of dementia, age-related, vascular, Alzheimer's. In your opinion, or does research support that they all basically are the same thing, they just have different presentations?
That's a good question. Alzheimer's disease is a subset of dementia, of cognitive impairment. Things like vascular dementia can happen from a stroke or from a TBI or CTE, the chronic head injuries, anything that interrupts or reduces the flow of blood to the brain, the blood supply to the brain. I think Alzheimer's, to me specifically, is this glucose deficit problem. The other forms of dementia probably have a glucose deficit for different reasons. I think, and this is my opinion, I don't have a lot of science to back it up, a ketogenic diet probably is beneficial for all of them. The extent to which anyone would improve, I don't know, but I think keto is worth trying for all of them. They're similar, but they happen for different causes.
Another question for Ms. Berger. Thank you for presenting the evidence supporting or debunking the myths surrounding beta amyloid plaques. I thought that was really interesting. And along those lines, I know along with beta amyloid plaques are also neurofibrillary tangles that are talked about a lot. Can you speak on those a little bit and perhaps the role that they play either in preventing or in causing issues for Alzheimer's disease?
Right. So these neurofibrillary tangles are also another sort of physical hallmark of Alzheimer's disease. And so the amyloid plaque builds up outside the cell. The neurofibrillary tangles are inside the cell. And the cell, you remember the picture of the neuron, it has that really unique shape. There are proteins that, like microtubules, that form that shape, form the axon, form the dendrites. It's like the skeleton of that cell. The neurofibrillary tangles happen when some of those microtubules, some of those proteins get misfolded and jumbled into these tangles. And oddly enough, insulin also plays a role in that process. I honestly don't remember the exact detail. It's in my book. There's an enzyme that is either, yeah, but tau isn't the enzyme. It's the tau. Yes, so it's GSK3 beta glycogen synthase kinase. You guys might know more about it than I do. There's a particular enzyme that regulates the formation of those tubules, the proper formation. And when that enzyme is not working properly because of insulin, it's actually an insulin deficit in the brain. This is something I didn't have time to get into in the talk. A lot of people with Alzheimer's they have too much insulin in the periphery, the rest of the body, and they're hypoinsulinemic. They don't have enough insulin in the brain. It's the lack of insulin inside the brain that is leading to those tangles. But I still think we're going to have all these drugs now. All the amyloid drugs have failed. Now they're going to have all these tau drugs that are going to fail because you're still not addressing the root cause. So yet the tangles are going to be a major player in Alzheimer's, but the question again is why are they happening? And they're happening because of insulin.
This is for Amy or any of you guys. Have you noticed that using exogenous ketones for people in Alzheimer's or progressive dementia helps or can be used to buffer that?
So I'll give it to Dr. Nalley in a minute, but I had to skip. I actually was going to answer this on one of my slides that I had to skip. The exogenous ketones, to me, in a situation where you have someone who's literally losing their mind, their brain is not getting enough energy, give them the ketones any way you can. Ketogenic diet, exogenous ketones, MCT oil, coconut oil. Get ketones into that person's brain any way you can. If they are young enough and able and willing to adhere to a ketogenic diet, do the diet, and maybe give them coconut oil, MCT oil, and the exogenous ketones. If you have someone who's very elderly or very severely impaired, good luck getting them to do a ketogenic diet. I mean, let's be realistic. If you're a caregiver or a loved one, good luck getting them to do that diet. So when they can't do that, give them the ketones, because will it improve their memory and behavior in the short term? Yes. Is it going to do anything to undo the metabolic problem that's causing that? Probably not. But to improve your quality of life as a caregiver, to improve their quality of life, get the ketones any way you can.
My average patient population, the average age in my patient population is 67. And so I see a large amount of Alzheimer's dementia. And the biggest challenge is that when you have Alzheimer's, you forget the last 10 years. So you're stuck in the food pyramid. And so most of those patients want to eat carbohydrates because that's what they were told they were supposed to be eating. And they get stuck in that pattern. So it's hard to change that diet. What I find is that giving them ketones dramatically improves their short-term cognition. My wife's grandmother, for instance, as a case study, she could watch, her favorite movie was The Sound of Music. She could get through the first 20 minutes and then forgot what the movie was on for. When using exogenous ketones, she could actually watch the entire movie and then sing the song afterwards. Now, that only lasted until the ketone wore off because she didn't change her diet and the insulin levels stayed high. The struggle was to get her to change her diet because she loved bread and she couldn't remember why she wasn't supposed to eat bread. And so there's a little bit of a tie there, but short term, yes, they're very effective.
I'll only add one thing. We don't need to speculate much. There are documented published reports. You could look up the work of Mary Newport, a case study of actually putting the person into ketosis via exogenous ketones and detecting real-time improvements, quantifying them. So there is, in fact, published reports out there.
Alrighty, we apologize for anybody who had a question. We're running out of time. Why don't we go ahead and give a round of applause to the panel? And we'll be back in 5 minutes.